Hey there, y'all. We're going to go through what is called composite area today, okay? And composite means there's just um, a bigger shape that's made up of smaller shapes. So we're going to be looking at, finding a shape that's just like got this whole big solid area here. And then there's also going to be shapes that have shaded areas, and we're going to have to do some subtracting there. So we're just going to go through all the things that composite area covers. So this first shape, we can see like it's a big shape here, but it's not, just a rectangle or a triangle or, a parallelogram or whatnot. It's actually, we can see here, there are several different rectangles that we can find in this shape. Now, the way that I'm going to break this shape up is not the only way that you can do these, okay? This is just how I am choosing to do it, the way that I see that it's easiest to do. And so these problems, it's more about the method, rather like the concept of it, rather than exactly how you go about getting the answer. So for this one, I'm going to break it up into 3 rectangles going vertically like this. Okay, and this is just how I'm seeing these 3 rectangles. Okay, let me make my pen a little bigger there. Okay, this is just how I'm seeing these 3 rectangles and how I'm looking at using the measurements that they have given me on this to get the area of these different shapes. So the first thing I see here is this big rectangle on the left-hand side. I see the height, okay? The height here is 8, but I need to know the width of it. I need to know this part here. So my question is, how wide is this part? If I look, the whole shape from end to end is 10 units. And then what I gotta do is I gotta look, okay, what other horizontal measurements do I have? So I have this one at the top of this rectangle. I have this 1 right here at the top of this rectangle. And I have the 3 at the top of this rectangle. So I say 10 is equal to what plus 1 plus 3. So basically I'm going to take the 10, the whole thing, I'm going to take away the 2 parts that I know, and that'll give me the part that I don't know. So if you do 10 minus 1, you get 9, and then 9 minus 3, you get 6. So this little section here is 6. So again, it's just seeing how you can use the information that you have to get the information that you need. So now this rectangle, the formula for the area would be base times height, okay? So 6 times 8, which is 48. So this section right here is 48 units squared. Now this next rectangle, I see it's 1, it's 1 wide, and now the height of it, okay, it's from here down to there. Again, I need to look at my vertical measurements this time. So I'm actually going to switch to a different color. Okay. This part here is 1 vertical part. And then the matching vertical part that I need is this 2. All right. I can see that this section is 6 tall. So from the bottom up to the top here, this is 6. And then it's split up into 2 pieces over here. I have 2 and then this other part. So I think, okay, 6 minus 2, well, this part has to be 4. So the area of this section is 1 times 4. So that is 4. And now our last section. I have the horizontal measurement 3. And then it goes all the way from here down to the bottom. And I know the height of that whole thing is 6. So I have to do 3 times 6. So that is 18. So I need this 18, the 4, and the 48. Those are the areas of the 3 rectangles. So to get the total area, I add them. 48 plus 4 plus 18. So add that up, 48 plus 4 plus 18, and that will give you 70. So the total area of the shape is 70. So the concept, guys, is to take the shape, break it down into the smaller pieces that you see, and then add the individual pieces back together if it's all just like one big piece. Okay, next one. We have to find the area of this whole shape together. So what we need to do is kind of look at the shapes that are here. Right now, it kind of looks like it's a rectangle. Like you can kind of see here, this is a rectangle, right? And it's got this like diamond looking thing over the top of it. Okay, you can see it like that. But I think a different way that you could go about doing this, and again, the way that I'm doing this is not the only way that you can do it, okay? What you can do here is actually look at these two shapes. These two shapes are both trapezoids, okay? So what we can do is actually find the area of this trapezoid, and I can see that over here on the other side, these two things, like their tops are equal, the bottoms are equal, the heights are equal, okay? I can find the area of one trapezoid and multiply it by 2. And the reason why I know that they're trapezoids is if you look carefully, you see the top and the bottom here are parallel. So that tells me that I can, in fact, say that it is a trapezoid. So I'm going to find the area of this small trapezoid first. So the area of a trapezoid, remember, it's base 1 plus base 2 times the height divided by 2. So this is base 1, 5. Base 2 is the bottom here, 8. Our height, it's going straight up and down, 4. Divide that by 2. So 8 plus 5, 13. Do times 4 and divide by 2. So I do 13 times 4, I get 52. Divide that by 2, and you get 26. So this trapezoid is 26, and this trapezoid over here is also 26. So that's the area of your trapezoids. Now I'm going to look here in the center. I can see that I have actually 2 triangles. Okay. I have 2 triangles, and they're both the same. And I know that they're both the same because this longer side is marked congruent on both of them, and the shorter side is marked congruent on both of them. And they share the side in the middle, so they are congruent by side, side, side. Okay, now I have to be able to find the area of them. And to find the area of them, I have to know the base and the height. I'm looking at the triangles like this, okay? The base is this side that they're sharing between them, so it's 16. Now I need the height. The height of our triangle is going to be perpendicular to that base. So I need to know this measurement right here. From the corner to that edge where they're both sharing. I need to know this. Now I'm going to figure that out by looking at my side measurements here. I can see the top of the triangle intersects with this 5-foot part right here. And then this bottom side of it is at the 8-foot part. So now I just say, oh, okay, what's the difference between 5 and 8? Well, it's 3. So my height right here is going to be 3. So now for the area of our triangle, it's base times height divided by 2. So 16 times 3 divided by 2. So 16 times 3 is 48. Divide that by 2, and you will get 24. So the area of these triangles are each 24. And so again, I used the base, which is the piece that they're sharing here between them. And then the height of it is right here. And I found that height because I looked at the difference between where the top of the triangle is and where this bottom of the triangle is. And so I said, okay, this one only goes to 5, but this one goes all the way to 8. So I did 8 minus 5, and that gave me the 3. So that's how I found that. And so now what I have to do is basically to find the total area is add up the 4 pieces. So I have 2 trapezoids that are each 26, and I have 2 triangles that are each 24. So 26 plus 26 plus 24 plus 24, and I will get 100. So the total area is 100. All right. Our next shape here, you can see this shape. It looks like an ice cream cone kind of, but it's really made up of a triangle on top and then a semicircle on the bottom. So first thing, area of the triangle. Okay, your triangle, it's base times height divided by 2. Remember, your base and your height have to be at right angles to each other. So our base is this whole distance here, which is 15. And our height is this distance, which is 20. So divide that by 2. So 15 times 20, that's 300. Divide by 2, and we get 150. That's the area of the triangle. Now the area of the semicircle. Okay, remember the area for a semicircle, it's pi r squared divided by 2. So we have to find the radius. You have to be careful on this one here. What they've given us on this one is the diameter, okay? They've given us the diameter. So what we need to do is take the diameter and divide it by 2. Because remember, your radius is the diameter divided by 2. So 15 divided by 2, it's 7.5. So now we're just going to plug it into our formula here. Pi times, and then remember, r squared, it's r times r. So 7.5 times 7.5, and then we only want half the circle, so we divide by 2. So let's put that in our calculator. So 7.5 times 7.5 times pi, and then divide that by 2, and we get 88.35. Okay, so we're going to look at the second number here, and that's going to make it round up because 5 and up we round up. So it's 88.4, and that's for our semicircle. Okay, that's a semicircle. So now to find the total area, what you'll need to do is take the triangle, which we got is 150, and add to it the semicircle, 88.4. Okay, so 88.4 plus 150, and you will get 238.4, and that would be feet squared. So there you go. Okay, our next problem that we have here is called shaded area. So we need to find the area of this shaded portion here. Okay, it's 15, not part of it. So we have to look at what the overall shape is, and then we have to look at the part that we're going to take out. So whenever you're doing shaded area, there's going to be like a big overall shape, and then there's going to be a piece that you have to subtract out. Okay, the big overall shape for this picture is this parallelogram. Okay, and what we want to do is take away this rectangle that's on the inside. So what we're going to have to do, okay, the shaded area, it's going to be the area of the parallelogram, and we're going to have to subtract out the area of the rectangle. Okay, because we don't want that part. So basically, whenever you're doing shaded area, you're just finding the part that you don't want, and that's the part you're subtracting out. So what I'm going to do is I'm going to first find the area of the parallelogram. So the area of the parallelogram. Okay, and I'm labeling all this so that I know what I'm calculating. So the area of the parallelogram is going to be base times height. Okay, and remember, your base and your height are at right angles to each other. So on this parallelogram here, we have this is our base. It's 27. And then we have to look. What is the height at a right angle to it? 24. Okay. If you do 27 times 27, you're not getting the correct height. So the base is 27 and the height is 24. And I want you guys to notice something. When you see dashed lines on these kinds of pictures, that's not part of your figure. Your figure is defined by solid lines. These dashed lines are just to show you like heights and things like that. So our base is 27. Let me fix the pin here. Okay, our base is 27 and the height is 24. So do 27 times 24. So that's 648. So that's this whole parallelogram. That's the whole thing. And we don't want the whole thing though. We want to take out this rectangle in here. So now what we need to do is find the area of just that rectangle. There we go. Okay. So the area of the rectangle, and again, a rectangle, it's also base times height. So I can see my base is 24 and my height is 12.5. So do 24 times 12.5 and we get 300. And so now the area of the shaded portion is the area of the parallelogram, the big shape, and then you take out the piece that you don't want. So the area of the shaded portion is going to be the area of the parallelogram, which is 648, and then we take out that 300, which is the rectangle. Okay, and so 648 minus 300 is 348, and it's units squared, whatever it's supposed to be. So that's how you would get that one. All right, last couple. Okay. I'm going to show you a couple here. So number 5, you have to look at this carefully, and you have to know, again, that the solid lines define where your figure is. So these dashed lines here are to kind of show you like things that you're going to have to subtract out. So if you look carefully, we can see there's an overall shape here of a trapezoid. Okay, there's an overall shape of a trapezoid, and we want to get rid of, because we have to follow the solid lines, okay, we want to get rid of this semicircle, and we also want to get rid of this parallelogram right here, okay, because we only want this section here. And so you have to again see that this is a trapezoid and we're taking out these pieces. So we have to find the area of the whole trapezoid, okay, and then take out these 2 blue sections. So let me erase all this pen. So this is kind of like a shaded area type problem, except they just don't have anything shaded. So first thing, we're gonna take the area of the trapezoid, because that's the big overall shape. Okay, area of the trapezoid. So remember, it's base 1 plus base 2 times the height divided by 2. Okay, base 1, easy, 7. Base 2, it's got to be this whole thing. We see a 6 here, and we see a 3. So together, that's got to be 9. So 9. That's our base 2. Times, now the height is 20, divided by 2. So 7 plus 9, which is 16, times 20, and divide by 2. So we will get 160. Okay, so the whole big trapezoid is 160. Now we're going to find the area of the parallelogram and the area of the semicircle, and then subtract that. So area of the parallelogram, again, it's base times height. And just look at your parallelogram. Let me get another pen. Okay. The base of it is 3, and the height in here is 4. So it's 12. And then now we'll get the semicircle. Okay, area of the semicircle. It's pi r squared, and then we only want half, so divide by 2. So now we have to look carefully at our picture here. This 6 is all the way across, but we only want half of it. So what is 6 divided by 2? 3. So our radius is 3. So it's pi times 3 squared divided by 2. And remember, 3 squared is 3 times 3. So we have pi times 3 squared, which is 9, divided by 2, and we get 14.13, which will be 14.1. Okay, and then now to find the area that we want. Okay, remember, this is the area that we want. See, we're tracing the trapezoid, but we're going around the parallelogram and the semicircle. Okay. Okay. So we're going to take the area of the trapezoid, and we're going to subtract out the parallelogram, and we're going to subtract out the semicircle. So area is going to be 160, because that's the trapezoid, minus 12 for the parallelogram, and minus 14.1 for the semicircle. So 160 minus 12 minus 14.1. And so we get 133.9, and it's whatever units squared. All right, and then the last kind that I'll go through with you guys looks like this one here. We look at this, there's no like dividing lines or anything, but we can draw one in to help us. So what I would do is I would split this shape like this. Is this the only way to split this shape? No. Okay, that's just how I'm deciding to do it. It might not be the way you decide to do it. Okay, there's other ways to do this as well. So I've created a rectangle on top and a trapezoid on the bottom. So I'm going to go ahead and I'm going to label things. Right here across the top and the bottom of this rectangle, I know they're both 7. Okay, so now for my trapezoid, I know the basis. Now the only thing else I need to know for the trapezoid is the height. Now look here, from top to bottom, the whole figure is 6. But I need to see right here where this dividing line is. And I can see from the top to where the line is, it's 3. So if the whole thing is 6 and this section right here is 3, well, what does this part have to be? It also has to be 3. So that's my height. So I'm going to do the area of the rectangle, which again is base times height. So 7 times 3 is 21. And then I'm going to do the area of the trapezoid. So it's base 1, 7. Here, so 7 plus, and then the bottom base is 12. And then the height is 3. And we divide by 2. So 7 plus 12 is 19 times 3, divide by 2, and we get 28 0.5. And so now for the total area, it's just taking these two and adding them. So 21 plus the 28.5. And so you would get 49.5, and it's millimeters squared. Okay, guys, so that's basically it. So if you see a shape that's just got a couple pieces and you can divide it up, find the area of the individual pieces, add them together. If it's a shaded area question here, like number 8, you find the area of the big shape. So I do the area of this big old rectangle here. And then you have to find the area of this smaller one in here. And I would split this up into some little rectangles there. You know, find the area of those little rectangles and subtract them from the big one. So that's the main thing. You're either adding areas together or you're taking a big area and subtracting out a small one. And of course, if you got any questions, ask your teacher, come see us during our Zooms. We are here to help you. See you guys next week.